Hi, this is Martha Page McMurray doing my first video reflection. It's for 1C on the basics of model and instruction. Our model that we use, and I say we because we do all of our planning together, it's a hybrid project-based and direct instruction model where we do a lot of practice activities because in chemistry and the sciences and what I teach, doing word problems is a large part of what enables the students to complete or achieve mastery. So in this, we blend project-based learning to increase their engagement with other activities and direct instruction because they all need it in order to understand the material. The experiential learning that we do, it also activates prior knowledge, and we try to make sure that for every unit we give them kind of like a hook so that they have some relevant experience, understanding of the material. So our components, I have to look at my notes so I make sure that I don't forget anything. We have direct instruction, and this is done to activate students' prior knowledge and to clarify and correct unit concepts. We try to do a project, and this is to help them largely, for traditional projects, to synthesize information into a product that they create to help them with higher order thinking and formulating like an opinion on a topic or trying to solve a problem. We realized that we were going to have to tweak this as we went through this planning process. It's the first time that we've done projects. We've tried to do projects for each unit. They present and discuss the project with the class so that they are more fully engaged and take responsibility for their content and their learning. They do some kind of reflection activity on acquisition of skills. We used to do formal reflections after our projects, but we also do warm-ups and exit tickets, which allows them a quick reflection on their work. Then we have ample opportunity for practice, and then they take a formal or a traditional assessment. Kids still need help with test taking skills, and a lot of the ones that I have say, "Oh, but Miss, I don't take tests well." Well, they can learn how to take tests better. What I Sort of a better explanation of the benefits and weaknesses. So our model, it includes increased engagement due to a variety of activities. Last year we did worksheets and other paper-based activities for practice, and it did not inspire students the way that we had hoped it to, or at least to capture all students. Some people like working problems. They seem to have a little bit more investment when we do activities that span the course of a few days, whether it is a traditional project or it is an inquiry-based activity that helps to train them to think for themselves and think through problems for themselves. And as the year progressed, we realized that we're going to have to do more of this, or we're going to want to do more of the multi-day activities because traditional projects are not as good at exposing the kids to the content. We typically do the project and activities as an introduction and then clarify and do practice afterwards. Weaknesses. So the weaknesses definitely include difficulty finding traditional projects that we think are the best way to introduce each unit, like I said, and traditional labs in many cases, or in some cases, we found are better at giving them exposure to the content. The planning process is fairly straightforward, and it's what I've done for a little while after learning more about backwards design. So first we examine the TEKS that we have to cover, and then we look at the essential standards that we have chosen. Our school requires us to do that at the beginning of each new year when we do in-service. We try to look after we figure out the TEKS that we have to use and our essential standards that we're going to focus on. We then try to look at the unit exam to do backwards planning. Sometimes, since all of us have taught chemistry before, we at least talk about what we remember from last year, and then we'll review the exam early on in the unit if we end up not having time to do it very prior to doing planning. And I was exposed to backwards planning when I taught biology, which was really, really helpful. The project, maybe we plan the project or the major activity, and the reflection after we do backwards planning, we look at what activities have worked well in the past for us. Then, based on that and and what we feel is going to be best for that particular unit. We decide on the type of project, the nature, and then after that, the depth of the direct instruction that we're going to need to give them. Um, the long form activities that we have found, we've developed sometimes on our own, but we found a lot of stuff on the web that teachers pay teachers and things like that. And we decided for some units that additional labs with write-ups, again, are the best way to go. After that, after we do the project, we continue with our direct instruction, as I've indicated, and we regroup with formative assessments. And just because we know our students, we talk to them, we have good kids. We adjust what we need to reteach or spend more time on based on the understanding of our students. So specifically to address adjusting the general planning template for each unit, the percentage and specific nature of our instructional strategies, it depends on the exact steps that we had determined for mastery. Whether it's math skills, whether it is being able to solve relevant problems. For example, we're going to try to do a project on climate change later in the year. We always look at what past activities have been successful. And once we decide on the activities, the basic activities that we want to do, and the type of project or major activity, the schedule usually becomes clear. We fill in with direct instruction, new practice activities as needed, and then we retweak our sequence as needed as we do formative assessments and just assess the kids while we're teaching during class. We make sure to alternate the types of activities, both to differentiate for different learning types and also so the students don't get bored. So we don't do scavenger hunts for each unit, but they really do like those. We do an assessment. We do a pretest before the assessment always, and then we determine the final review before the assessment based on the data from the pretest. So, saying a lot of ums here, I gotta scroll down in my notes. Surprised my cat hasn't run through this video yet. So I guess in summary, our hybrid model, it allows us the flexibility to choose from a wide variety of teaching strategies. And also when we decided to do project-based learning, it keeps us in mind that for future units that we need to figure out a large project or a major activity. These activities, we think, better authentically engage students, and it helps to make them think for themselves and teach themselves, which they're going to need to know in the future. And it gets them to think at a higher level, so with higher order thinking activities, not just remembering and recalling, and even higher than analyzing. They get to immerse themselves in chemistry, and we hope it will pique their interest for chemistry later on when they encounter it, because it is involved in everything. And the basic steps in my planning process, they would be the same as, like I said, I've learned the value of doing certain things like backwards planning and the essential standards determination for the past couple of years. And when we do these projects and major activities, I really think that it helps these kids to access the content and then be able to remember it, at least some of it long term. So it's my hope that by doing this combination of activities, that it's going to help their confidence and problem solving, and hopefully retain some of the knowledge for the essential standards that are going to help them better parse chemical and scientific information that they encounter later on in their lives. Thank you for listening to me. And if you have any questions or need any further clarification, please, I know you will not hesitate to ask. Anyway, thank you very much.